Think about this, what's the field is perpendicular to the board, right, coming out toward you? The velocity is in the plane of the board.
Oh, that's right. So
Geometrically,
it's already perpendicular.
It's already perpendicular, right? So it's the whole velocity that you use. If it weren't perpendicular, it would be more like this or something, then you'd have to have information about the angle. Okay?
What exactly is your?
Are you ever gonna,
If the particle, the proton, whatever it is.
are
Was
you
it-
ever gonna do it like the particles moving like three-dimensionally, like out or in?
That would, well, if the particle's moving straight out, then what?
You just do
It is
90
not-
or whatever
It's
it's.
not
Then
perpendicular.
it's coming in this direction.
What, so how much force is it on that? None,
Oh yeah, none.
okay, because you can't do your
But
hand
could
like
it come, like,
Yeah.
this way, like how would you?
But yeah, this way would be, you wouldn't draw it this way either. Remember the way we drew it the first day?
Yeah, with the two poles.
So it was like this. And the field was say like this. Which one of those poles is the south pole?
The bottom one.
Like that. Okay, then you could show it coming in at an angle and that would be much clearer. Okay, one more thing.
To find the perpendicular velocity, would you, just do vectors and would you find?
Yeah, yeah, just find the component that's perpendicular to that. Let's look at the Earth again. The Earth behaves as if it has a giant bar magnet in it that's like this. Everybody comfortable with that now? We liked that the first day, but. Okay, so its field looks like this. Pretty much. In what direction are the arrows? Yeah, it does look like, it looks like them over me.
From
They're going this way.
with this out.
And out in space, there are cosmic rays. Who knows what a cosmic ray is?
No idea.
Joshua?
It's a highly charged particle. I know sometimes it can be like
It's an almost,
alpha particle.
almost, well, it can be alpha particles and be any thing that can be manufactured by a sun, which in a nova is some pretty heavy elements. So it could be carbon nucleus or something like that, and they're totally ionized. So what's their charge? If you take away all the electrons on a particle, they're positive, right? And they whip around in outer space at speeds close to the speed of light. So say, here's one coming. Whatever that is. If that could get to the atmosphere of the Earth, it could knock on atoms in the atmosphere and just burst them apart. And what would you get? Well, you get a lot of protons coming out, right, and neutrons and stuff. You get a big spray of radiation coming down. What do you think that would do to people on the Earth? I mean, you could get radiation sickness, you could get mutations that would cause cancer, you could get mutations that would cause strange babies, you could, all kinds of stuff. Not good, not a good thing.
Become a ninja.
But, yeah. When it hits the magnetic field of the Earth, it's gonna feel a force, isn't it? What's the direction of the force it's gonna feel?
Like,
It's gonna go into the board.
yeah.
Yeah, and it's got two components, right? It's got the part that's perpendicular and the part that's parallel. So the part that's perpendicular, or part that's, perpendicular will feel the force initially into the board. So when it feels that force, what's gonna happen? It's
Oh,
gonna
it
change its
continues.
direction, and it's gonna start to circle
Pushes it.
around the magnetic line, the field line. At the same time, it has some velocity that way, right? So what it's gonna do is do that. And instead of hitting the Earth in a populated area, where's it gonna hit? North of the South Pole. Okay. In this case, it's the North Pole, but it could just as easily be at the South Pole if it had been coming in at a different angle. So what the magnetic field of the Earth does is protect the Earth
Where's the penguin?
from, yeah, well, and it explains a lot about penguins.
With their mutations?
Have you ever looked at
Yeah,
penguins?
they're awesome.
They're so-
They don't
Unless
fly,
they're
which
not
probably
all
explains
day.
something.
Sorry.
So if it came in this way, then it would just spiral down. And what else does it do? As it comes down, it loses energy, right? Where do you suppose that goes?
Heat.
That must
The
be.
atmosphere.
Some of it probably comes out as heat, but even more
Light.
of it probably comes out as light. And we see the northern lights, yeah.
So
Happy
there we
radiation.
do that, we can do studies ourselves, when we experiment without that.
Probably not on a very big scale, because you would have to, they have to go down significantly. But, if you're close enough to the North Pole, you can see the aurora when there's a good, storm of, if the sun erupts a lot of radiation, you tend to see the aurora further south, stuff like that. And if you were in the South Pole, you would see the southern lights.
How come we don't like see it, like, we don't see it like moving?
Sometimes you do. I've sat on the end of a pier in the winter in Wisconsin and watched a ring of green, like oscilloscope light, just going like this. It's all kinds of weird things. You see them, or you see them shoot up and then come back down. So there's all kinds of stuff you can see, and it's really good. Have y'all seen them?
The northern lights.
We should take a class.
So where do you have to go? Do you have to go to
Montana's pretty good.
Really?
I've seen them from Montana, certainly from Canada and Alaska.
Every night?
No, but when there's a good amount of electrical stuff coming in.
Will they tell you like?
Yeah, or it's pretty obvious.
So there's actually
It's
like
pretty
a positive reading in
Is it
Canada?
pretty frequent or is it like?
It's pretty frequent, yeah. And it's dimmer and brighter. Okay, so what we're gonna do, we've got about 2 minutes left in class. When the bell rings, I want you to make sure you have a physics book, because you now know enough to do all of the homework. Okay? I know you're ecstatic, but you have a big exam tomorrow, and it would be nice if you didn't have
Because
to
the
think about
current
physics
always
homework
goes
to
from
do
the
Thursday.
side to the side.
Well, many people have an exam. Even though you're gonna be out of the exam by this time tomorrow, I don't think you're really gonna wanna have to worry about physics work. So, when we have the break, take a break, and then reconvene in the lab room, and we'll spend a period working on it, okay?
Do we have a lab due today, or do we
We
turn
do
that in?
not, you have turned in, you have gotten your first lab break.
Alright, just making sure.
I have graded, except for Courtney's and Arias, I have graded my last lab. Oh, just for
Miss Miller? Oh. I have to leave right now.
Okay,
Other way.
I'm assuming you're gonna check out with the office.
Yes, I will.
Can I go to the restroom now?
Yes. Yeah, I think it was a good thing that you stayed.
Yeah.
Thank you.
Fuzzy guns. Is this thing still recording?
Oh, yeah, you push a little silver button,
Where's that? Oh.
right on the
In-
back.